Welcome to lesson 18, all about polygons. Polygons really stands for many sides, and we can look at a number of different shapes that fit this category of polygons. Most of these are probably very familiar. A three-sided figure is known as a triangle. A four-sided figure has the family name, or the larger name, of quadrilateral. Then, of course, our five-sided figure is a pentagon. Six-sided figure is a hexagon. Our seven-sided figure, not as common, but is heptagon. Moving over, we have our eight-sided figure, octagon. A little bit more familiar. Our nine-sided figure is a nonagon. 10-sided figure is a decagon. 11-sided figure is a hendecagon. And a 12-sided figure is a dodecagon. These different shapes make up the primary shapes, though we could get larger with 13, 14, 15 different sizes. But in general, we have these shapes that we can work with, and we want to get to know a little bit better. A couple key characteristics about polygons happens to deal with what are known as vertex or vertices, if you want to use the plural, or in other words, where two sides meet, right? Side being our lengths and widths of, in this case, a rectangle or quadrilateral. But we have our vertex at different points, and our different vertexes help us to name our shape. So I could call this quadrilateral A, G, D, C, or I could reverse it and go in a different order. I could go A, C, D, G. Clockwise or counterclockwise doesn't matter as long as you are truly connecting the dots. We don't want to go A, D, C, G, because that would make a shape that would look like A, D, C, G, which is technically not a polygon. We have this idea, and we're going to use this information as we move on. First of all, can you name each of these shapes? Go ahead and count the sides and name both of these shapes. If you pause the video, you maybe are kicking yourself a little bit because I gave you time to count them before I moved on. However, as you counted both shapes, you probably came away with one term. Hexagon. Because both of these shapes are hexagons. They are both hexagons because they each have 6 sides. However, they are not the same because one of them fits under the title of regular, while the other fits under the title of irregular. Regular shapes is really the key, the one we want to remember more. Not that irregular is unimportant. But regular means that all of the sides are the exact same length, or they are congruent. And when they're the same length and congruent, and we have a unique shape similar to this hexagon here, we would call that regular. All right? Usually we have equilateral and equal angular ideas when it comes to regular shapes. Irregular shapes still fit the name because only the sides give us the names, but they can have unusual patterns, as you can see. Along with understanding our polygons, we want to understand relationships between them, how they can be similar, how they can be congruent. And understanding the differences between these is important. First of all, we can really start with congruent. As we look at congruent, we're looking at the definition of really they're the same. Same length, same angles, same shape. All right. While sameness in this example is going to be an exact match, we do need to understand that congruent does not necessarily mean the same orientation, which means you could turn a shape and still have the same size, same length, and so be congruent. Go ahead and answer these two questions, right? Which one is congruent? And then, of course, which one is similar? Similar means they are going to be proportionate. Or we could say they have the same ratio. So they're going to look the same, but they're, for the most part, going to be different sizes, either larger or smaller. All right? But proportionate, proportionate would be more sense. We're going to have that idea. We'll use this as a sample to go through this idea. Finally, we end with what are known as corresponding parts. With shapes that are corresponding or congruent, right? We have two shapes, right? This shape here and this shape here. They are congruent. Even though they don't have the same orientation, they are the exact same size and the exact same shape. Because they are the exact same size and the exact same shape, we could talk about how they correspond with each other. All right. As we look at this, we could ask the question, which angle in triangle ABC is congruent to angle Z? So we want to know which does this angle match with. If we look carefully at our triangle ABC, we would understand that this side here matches this side here, just like this angled side matches this angled side. And in the end, because of that relationship, we would understand that angle C would correctly answer that question. Before you take time and solve this sample problem, realize that congruent parts also work with similar triangles also. The difference goes back to our definition. If we have similar triangles that have corresponding parts, we need to understand the ratio of correspondence. This lesson may cover that idea, or it may not, but be prepared. Go ahead and answer the sample questions then, and have a great day.